Hi everyone, and welcome to our video on the logarithmic functions, where we're looking at the definition and how to rewrite and evaluate log expressions. So our log is the inverse of the exponential function, and it's defined by using this. So if we have an exponential form, so there's the exponential form, we can go back and forth with it to get the logarithmic form, or we could use the logarithmic form to rewrite it in the exponential form. Okay, so, but notice the vocabulary, the b would be called the base in both. So the base in the exponential matches the base in the logarithm. Okay, so these logarithms are helping it solve for a variable. So like this x is often something that we might need. The log gets that x by itself. Okay, so the log, so it's like it's a new function to help us solve certain equations. There are also two special logarithms. One is called the common log and one is called the natural log. The common log is when we have base 10, and we usually just write it as log x. So log base 10 of x, we usually just change to log x. And then the natural log is when the base is e, and we'll write log base e as just ln of x. So then that's usually how we say it, ln of x. Okay, so I just kind of put a comma there to try to put a pause, so ln of x. All right, well, anyway, so let's show how to rewrite these logarithmic expressions. So what I like to call it, I usually say smile rule. So the definition I call the smile rule, because the way I think of it is this base on the log connects to the far value or variable or expression on the other side of the equation, and we get this kind of like, smile shape. Okay, so this is 4 to the second equal to the leftover 16 right there. And then this, we can see it is true. 4 squared would be 16. Okay, so this is how we can rewrite this log into this exponential form. Now, number 2, same deal. I'm just going to say, well, this is the base 12 connected to the far value over there. It'd be 12 to the third equal to this leftover t. This one we can't check because it's not just regular numbers, but it does match the way that the definition worked. Okay, this one, number 3, well, the log is blank, so that means you could put a little log base 10 there, and so that way we see the base is 10. So base is the most important part to both of those style functions. So the base is 10, and I'm going to connect it. So 10 to the negative 2 is equal to 0.01. Now this one you could check. It is true. So if we plug 10 to the negative 2 into the calculator, we do get 0.01. Or if you use your rules for powers, so this is just a side note, 10 to the negative 2 is the same as 1 over 10 squared, and that would be 1 over 100, which does match that decimal form also. Okay, so that's I'm just showing the verification of the above. Okay, so that is how we connect it. Now, number 4, it's ln. So I'm going to rewrite it to be log base e of x plus 1 for this problem. So we don't need to rewrite it, but I think it's nice to see it here. And then that way I'm going to connect my base e to the far letter or whatever's on the other side of the equal sign. So it'd be e to the m. So the base is still e to the m, equals this leftover x plus 1. There we go. All right, and then that also matches the form for our rule. We can't check it because it's not regular old numbers, but it does match the form. All right, the next thing that we'll do is go back the other way, where we have these exponential expressions, and we're going to change them to logarithmic expressions. All right, so it is making sure, again, I'm thinking the base. The base is 5, so that means I want log base 5 of something. Well, kind of like what we did on this one, the base connects to the other part of the equation, the other side of the equal sign. So this base 5 should connect with this 125, and then it would equal 3. Yeah, and then this is where I would just do, so in the purple, I would just say, here's a quick smile rule check. This would be 5 to the third equals that 125, okay, which is what we started with. So I think it's easier to see the log back to exponential than the exponential to the log, but either way, there we go. On these log problems, notice the base is a little subscript. So on these first two, I mean, that typing is the way that it should look. Same deal right here. I'm trying to keep that 5 a little subscript down below. And the 125, this would be called the arguments. And you can even put it in parentheses to verify it or to make sure we know exactly what's there. But that is a little subscript. Okay, number 2, our base is e. So that means I'm going to write it as log base e of the far side of the equation, so r, equals the exponent z. And then for this problem, again, I can very quickly eyeball check here. Let's put it in purple. E to the z is r. But let's box the other form for this log base e. So I'm going to write my final answer as ln of r and then equal to z. Okay, so the special case there, ln, instead of log base e. Now, they are the same. You could box this. This is equivalent, but this is the way that it might look. Okay, and it kind of looks like h. Let me change that. There we go. Make it cursive kind of to make it a little better. And then even again, you can put that argument there in parentheses just to see it better. It's optional, but often it's a good idea. Okay, number 3 here. Well, here they give us the cube root. So that means we can have a power. So first thing I want to do is just rewrite it. So we currently have 1,000 to the 1/3. So I didn't do any rule yet. And then now I see, well, 1,000 is the base. So I want log base 1,000. So the base is whatever has a power to it. Okay, so the log base 1,000 of the far side of the equation. I'm going to put that in parentheses and make it bigger so it looks like it's not a subscript. Equals the 1/3. Okay, and then that's going to be good, and I'm going to box it now, but in the purple, just quickly double check, smile rule. 1,000 to the 1/3 is 10. Yep, it's the same as what we have right above. Okay, and then number 4 in this style problem, I need to rewrite this radical, so I need to see it as a power. So p to the w over m, so there's our new power on that. And then that way I can see, well, this is the base for this exponential part. So p is the base for our log as well. So log base p of the other side of the equation, so t, equals the exponent w over m. And let's go ahead and box it. And one more time, just in the purple real quick. P to the w over m is this leftover t. Yep, it matches. Okay, so there's our final answers to these problems. Let's write these ones out. So here it does say evaluate by hand, so without a calculator. Often it's better. It's very quick to do it without a calculator. Anyway, number 3 and number 4 we could. Number 1 and number 2. Without a calculator, sometimes these buttons aren't even there. I mean, some of them have it, but again, I think it's just going to be just as easy to do this by hand. All right, so the way that we can do this, or the way that I'm going to do it for these problems is I'm just going to say that this should equal something. I'm going to write it as equal, and I'm just going to get my answer box ready. And then now I'm just going to say, well, how about I write it using my smile rule and say 7 to whatever this is equals 343. Okay, and then now it's either just guess and check or take this number, the 343. I'm going to do prime factorization. Well, 343, you can multiply 7 and 49 to get that. And then another 7 and another 7 would give 49. Okay, so 343, so I have 7 to this box, is the same as 7 cubed. So that way I can see, well, this answer should be that 3, because then it is a match. Okay, so our final answer up here, let's go back and put it, is 3. So log base 7 of 343 is 3. And this is where, again, we can very quickly check. 7 to the 3rd, we could definitely plug into a calculator, and it would be 343. Okay, so that in the purple was just checking it. Let me go ahead and block that on and off. Okay, so, and what I meant, so here is me doing the kind of scratch work with prime factors. So I was just thinking anything times anything to give me the 343 to start it off. But I said on right before, you could also kind of guess and check, like, well, one wouldn't have worked, and then just kind of count, well, 2 is only 49, so that doesn't work. 3. Yeah, 3 would work. 7 cubed is 343. Okay, so that way we've got it correct. Okay, so that's the other way that we can break these down. But either way, I think this is the best way to verify. Just quickly double check with rewriting it to see if it is good in that exponential form. Okay, so I'm going to do the same thing that I did on that last problem right here, where I'm going to say, well, this should equal something, just getting my answer kind of ready. And then from there, I could do my smile rule. So 6 to whatever that answer is equal to 1 out of 36, or 1 over 36. And here's where I can start to use my prime factors again. And you might see it a little quicker than 7s, but 6, or let's go down here. So here's my scratch work. 6 goes into 36 6 times. And that's the base that I have on my left side. So I'm going to rewrite that right side as 1 over 6 squared. So 36 is 6 squared. And then we have a rule here that tells us you can use a negative exponent to rewrite it as 6 to the negative 2. And so that way, now I'm using my highlighter again. This should be this because our bases are the same. So it looks like our answer should be negative 2. Okay, and then in the purple, just real quick, so my smile rule, 6 to the negative 2 is 1 out of 36, yes. And that one we can plug into the 6 to the negative 2. We could plug in to see it would be 1 out of 36. It is correct. All right, so there's that one. All right, let me continue kind of just blocking these off. Number 3, here we've got the log base e, so it's special, it's ln. So I could rewrite it. I think that helps for now. And then like before, I'm just going to say, well, it should equal something. And then that way I can now set up my smile rule. Okay, so my E, let me put that in blue so kind of match my colors like the last problem. Okay, now I'm going to say that this base E to whatever's in this box should equal this E to the 22/3. Well, look at this. This is a good problem because I don't have to really do anything. These two powers are the same. Okay, so that means my answer is 22 over 3. There it is. That one's done. Okay, and then this one also, again, very quickly, like in the purple. I'm just going to add my purple. Okay, so my smile rule, e to the 22/3 would equal this e to the 22/3. Yeah, it's good. Okay, so we verified it again really quickly with our smile rule, our definition of our log. Okay, and then our last one here, it's log base 10 really, so I can rewrite it of, and even this 10 I could rewrite as 10 to the 1/2. So I did 2 rewrites in one step there. So I put the base value and then I changed the square root into a half power. And then now I can do my smile rule. This 10 to whatever that power is should equal 10 to the half. And then look at this. Again, it's real nice. So these special logs are usually nicer than other logs, where now I do have the answer. So 10 to whatever's in this answer box should be 10 to the 1/2. All right, well, the answer box and 1/2 should be the same number. So that's it. So we got 1/2. And then one more very, very quick check. 10 to the 1/2 there is equal to this leftover argument, the 10 to the 1/2 check. Okay, it's good. We got it. Okay, so that's the basic deal on how to deal with logs. Okay, so you're just kind of thinking, rewrite it back and forth into exponential form, and the exponential form is something that we're a little bit more comfortable with, hopefully. But that's that. Okay, so if you do have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.